Hello and welcome to this bonus video on graphical comparisons. Here we'll look in more detail at some of the oddities we noticed during the main video. We're often asked for advice, and a common question is, what test should I use? The correlations are examples where a statistical test could be applied, and the next video provides many more summaries for hypothesis tests. However, we prefer to think of data analysis more like a voyage of discovery than a set of significance tests. What you notice in your data guides your voyage of discovery. So here we try to discover more about the problem there seems to be in the winter months. It's often useful to analyse one or two stations in detail first, then apply the results to all the stations. Here we prepare for that by producing a set of filters. We choose filter from factor and select the station as the factor. Choose all levels and return. We choose to filter to Graphical, as this is the station with the most oddities. We apply as a subset and we call it Graphical. Usually we filter within the same data frame, but here we will be doing quite a lot of work with the one station, so it's convenient to make a new one. In our new data frame, we apply another filter, this time to focus on the winter months. We filter by month and choose January, February, March, and December. Add the condition, and we call it winter. This time we choose to apply as a filter. Click OK. Red numbers on the left indicate that a filter is in operation, as does the message at the bottom of the data. Get the correlations again to review the problem. Change the data frame to Graphical. Then complete as before, with the sunshine data as the variables. This time choose the month as the factor. Click Return and OK. The correlations are reasonably high, but these values are puzzling. Quite often there's more than 5 hours of sunshine at the station, and almost no sun according to the satellite. Discussion with the German Met Service provided two possible theories. The first is that the satellite changed in the mid-90s, and perhaps the data were better after that. Let's see. We filter again. This time, we add two filters. We filter for winter, adding January, February, March, and December. And then we filter to the year. We want it to be bigger than 1996. We name this Winter 1996. Press OK. Next, we go back and get the correlations again. We won't need to change anything in the dialog. We can just press OK. That doesn't seem to have made much of a difference. The other idea from the German Met Service was that the satellite estimates may not work so well when there's snow on the ground. Snow depth is measured at these stations, so that can be checked. Use the Compare Calculations dialog to investigate when the bias is large. This adds two more variables to the data frame. We'll use one of these new variables to investigate how often the deviation is large. We filter again, and we choose just the days when the difference is more than 5 hours. First, we add our months as usual. Then we find our new variable, absolute deviation. and we set it to be larger than 5. We call this filter WinterDev 5. Press return and OK. There are now just 102 days with more than a 5-hour difference. It's good to look at the data, so let's do that. The first row shows 7.2 hours of sunshine, and the satellite estimated just 0.3 hours. And there was snow. Similarly for the second day. The third day there wasn't snow, but that's different because the satellite is now more than the station. In the scatter plot, that's these values rather than those. Let's look further. To clarify, we can sort on snow. Now we can see how often there isn't snow when the satellite value is lower than the observed. There are 9 no snow days, and only 2 occasions are when the satellite is lower than the station. The other 93 days with a large discrepancy have snow. 95 of the 102 days are from this area, and 93 of them, so all but 2, are snow days. Perhaps this is a possible explanation. Let's try again with no snow days. We filter again. We add our months as usual. And we add an additional filter for there to be no snow. So snow equals 0. We call this winter no snow. Let's try our correlation again. That looks much better. The worrying part of the scatter plot has disappeared, and the correlations are now even higher. They are all over 0.9 and a 0.95 in February and March. It's also very quick to check for the other 3 stations. We tried quickly for Arkona, and the correlations are even higher. More investigation is needed, particularly on whether anything could be done on the snow days. If not, then perhaps the satellite estimates should be recommended only when there's no snow. Thank you for watching. Bye.